Hello everyone, this is another video covering the important questions from the exam point of view. So the next question is where the isocount is given to us as q is equal to 8 k raised to the power of 1 by 2 l raised to the power of 1 by 2 equal to 400. We had to find the slope of the isocount using implicit differentiation, calculate MRTS, which is marginal rate of technical substitution, at k equal to 25, l equal to 64, and explain its economic mean. Now the first step that needs to be done is writing the function in terms of fxy equal to 0. So we have to gather all the terms at one go, which is the function will become 8k raised to the power of 1 by 2 l 1 by 2 minus 400 equal to x equal to 0. This is important because we need to express it in the implicit form, which is fxy equal to 0. So that is why this is very important step to write. Then we know by using the implicit function rule, dk by dl is equal to minus fl by fk. This you should remember, which is dy by dx equal to minus x by y, fx by fy. It is in line with that. So now we have to find FL and FK. What is FL and FK? FL is the differentiation of the function with respect to labor and differentiation of function with respect to capital. Now if we do the function del f by del L, we will get 8 1 by 2 k 1 by 2 L minus 1 by 2. If we do it with respect to capital, we will get 8 1 by 2 k minus 1 by 2 L 1 by 2. The constant minus 400 will be 0 only. So then dk by dl, we know this formula. Putting in the values minus fl by fk, we will get 4k 1 by 2 L minus 1 by 2 divided by 4L 1 by 2 K minus 1 by 2. So that means this is going to give us K by L. So our function dk by dl is equal to K by L. We have been given the values also of capital and labor. So putting in the values, we are getting 25 by 64, which is equivalent to 0.39. Now MRTS, marginal rate of technical substitution, is 0.39, which means that 1 unit of labor can be replaced by 0.3 units of capital without changing the output. This is what the economic meaning of this term is. Let's look up at the next question. Consider the isocount 25. This isn't similar with the above one, so you can do it easily. Let's look up at another type of question. A consumer's utility function is given to us as Q1, Q2, where Q1 and Q2 are the quantities. Prices are P1 equal to 2, P2 equal to 6, and the budget income is given to us as 120. We need to find the utility maximizing bundle in this one. Now again, setting up the Lagrange. First the budget, let's make up. First step is to make the budget constraint. the budget constraint is 2p1. The equation is 2, sorry, let me first write the formula. P1Q1 plus P2Q2 equal to M. We have been given P as 2, so this is 2Q1 plus P2 is 6, 6Q2, M is given to us as 120. So this is the budget constraint. The next step is to set up the Lagrange function. Let me write it here. So L is equal to the utility function Q1 Q2 plus lambda, and like I explained earlier also, we first write it in terms of constant 120 minus, so this usually is the constant, so this whole will go in this, so the signs will change, minus 2q1 minus 6q2. So this will become 120 minus 2q1 minus 6q2. This is our Lagrange. Now the first order conditions require delta L by delta Q1 equal to delta L by delta Q2 equal to delta L by delta lambda, and all this should be equivalent to 0. Now doing it with respect to Q1 first, we will get, so basically you will have to differentiate this Lagrange with respect to Q1, Q2 and the lambda. With respect to Q1 we do it, which is Q2 minus 2 lambda, we put it equal to 0. Let this be our first equation. The second is delta L by delta Q2, so this is Q1 minus 6 lambda, put it equal to 0. Let this be our second equation. Delta L by delta lambda, so 120 minus 2q1 minus 6q2. Let this be our third equation. Now solving these three simultaneously, solving 1, 2 and 3, we get, in the exam always write step by step and write it very neatly. You will get better marks, and it's easy for you also to write it in better way. So Q2 is equal to 2 lambda, Q1 is equal to 6 lambda from 1 and 2 equations, so that means Q2 upon 2 is equal to Q1 by 6. So from here we get Q1 equal to 3Q2. If we put it in the budget equation or in equation 2, in budget equation we get Q1 equal to 3Q2, 120 minus 6Q2 minus 6Q2, 12. So we will get Q1 equal to 30 and Q2 equal to 10. So this is the utility maximizing bundles Q1 30 and Q2 12. Let's find out the utility also, the maximum utility. The utility function is given to us as Q1 Q2, so this is going, sorry, this Q1 Q2 10, yeah, so this is Q1 30 Q2 10 because 120 minus 6, so Q1 Q2 is going to be 300. So this is the maximum utility of this consumer, and the utility maximizing bundle is 30 comma 10. So by using the setting up the Lagrange, we have solved this question. Let's look up at one of the other types of questions as well. Okay, let's look up at this question. A firm's profit function is given to us as 60x minus 3x square minus 2x minus y square plus 20y minus 10. We have to find the stationary levels of x and y and check whether this is a maximum value and determine the maximum profit. Now what we are going to do, we are going to first write out our profit equation. So this is the solution of it. Pi is 60x minus 3x square minus 2xy minus y square plus 20y minus 10. So the first order condition requires delta pi by delta x to be equal to 0 and delta pi by delta y equal to be 0. Now if we find out delta pi by, let's find first delta pi by delta x, that is differentiating this profit function with respect to only one variable x. We can also denote it by pi x like this. So we get, if we do it, 60 minus 6x minus 2y, let's put it equal to 0, then pi y equal to delta pi by delta y equal to minus 2x minus 2y plus 20 equal to 0. Now solving both these equations, solving equation 1 and 2 simultaneously, we get 60 minus 6x minus 2y equal to 0 and 20 minus 2x minus 2y equal to 0. So we get x is equal to 10 from here and y is equal to 0. So our stationary point is x comma y, which is 10 comma 0. Now to prove whether it is maximum or minimum, we are going to find out the second order conditions. So this SOC is second order conditions. Second order condition is differentiating pi x with respect to x again. So this was our function pi x delta pi by delta x. We are again going to differentiate it with respect to x. So if we further differentiate it with respect to x, we are only going to get minus 6. Similarly, we are going to differentiate y with respect to y again, that to get delta y. This was our delta y. So differentiating this with respect to y again. So x is constant, we are only going to get minus 2. Next is delta xy, or either way is delta yx. By using the Euler's theorem, we know that it is going to be same. So delta x or delta xy or delta yx, that is going to give us minus 2. Now by using the conditions, let's see, pi xx, pi yy, and comparing it with pi xy whole square. So this is minus 6 minus 2, this is minus 2 ka whole square. So this is 12 and this is 4. So this is greater than 0. So if pi xx pi yy is greater than pi xy square, this is a case of maxima. Make sure that you know about these conditions, if it is less than or equal to, or if it is greater than, when it is maxima, minima. So because this is greater than pi xy square, this is a case of maxima, and we are going to find out next the maximum profit. The maximum profit pi xy, by putting in the equation of profit the values of x equal to 10 and y equal to 10, incorporating it in the profit equation further back, we are going to get 60 into 60x minus 3xy square minus 0, 0. So the profit will come out to be equivalent to 290. So this is the maximum profit that is there. So the stationary values of x and y are 10 and 0, and check that this is a maximum by using the Hessian determinant and determine the maximum profit. So the maximum profit is 290. So this is how we solve such type of a question, important question. This is all in this video. If you like it, do subscribe to the channel and share it with as many friends as you can.